In vitro dissolution testing models, these two are non-sync methods. Next, 3 and 4 are sync methods. What are non-sync methods? Natural convention non-sync methods. In that, A. Clean solvometer method, Nelson hanging pellet method, Levy static disc method. Okay. Next, second one, forced convention non-sync methods. Tumbling method, beaker method or Levy method, rotating disc method, particle size method, USB rotating basket apparatus and USB paddle apparatus. These are same. I already explained in the last class, rotating basket and paddle type. Next one, forced convention sync devices. Brewster Police adsorption method, partition method, dialysis method, rotating disc apparatus. These are the forced convention sync devices. Next, the in sync devices. Last one is the continuous flow or flow through methods. Parnowski method, Langer-Bucher method, Born and Walker, Tingsted and Regelman, modified column apparatus, Tekenaka method. These are the sync methods. 3 and 4 are sync methods. 1 and 2 are non-sync methods. I will discuss one by one. First one is a natural convention non-sync methods. First one is a clean solvometer method. So what is clean solvometer method? So this is the figure of clean solvometer method. This is the solvometer scale and here float is there. And here boat shape form is there. In this only we are placing dosage form. Okay. This instrument is called as solvometer. Okay. This consisting of carrier device, that is boat. This is float. And this is measuring bar, that is calibrated scale. And this one is the dissolution medium. So this consisting of carrier device, float, measuring bar, calibrated scale, dissolution medium. This carrier device, that is boat, that is surrounded by float. Okay, this is the float, no? And this is immersed in the dissolution medium. So this total assembly is immersed in the dissolution medium. And here measuring bar is extended from the float. Measuring bar is extended from the float. And this is, the float is just above the surface into the calibrated scale. This is a calibrated scale. When dosage form is placed in the board, the scale bar moves downwards to its lowest position initially. Okay. When the dosage form is placed in the board, the scale bar moves downwards to its lowest position initially. Next, as the dosage form dissolves, it rises gradually. Okay. So here, the loss in weight of the dosage form can be monitored by using solvometer. So the loss in weight of the dosage form can be monitored continuously by reading the scale directly. Okay. This is about solvometer method. Okay. This is called as solvometer. It's consisting of carrier device, float, measuring bar, calibrated scale, dissolution medium. The carrier device is surrounded by float. This is immersed in a dissolution medium. The measuring bar is extended from the float. This is just above the surface into the calibrated scale. When the dosage form is placed in the board, the scale bar is moved downwards. Next, as the dosage form dissolves, it raises gradually. So the loss in weight of the dosage form can be monitored by using this method. So we will monitor continuously by reading the scale directly. Go outside. Go. Wait for 1 minute. So this is the first one, salvometer method. Next one, Nelson hanging pellet method. Okay, Nelson hanging pellet method. So in Nelson hanging pellet method, this method is developed by Nelson. The name itself indicated that Nelson hanging pellet method. The scientist called Nelson. Okay, this method is developed by Nelson. Okay, this consisting of mounting the dosage form on the aluminum strip. This is the aluminum strip. The dosage form is mounted on this aluminum strip. Okay, means aluminum strip having provision for holding the dosage form. Okay, this is the aluminum strip. Here we are mounting the dosage form. For aluminum strip is having provision for holding the dosage form. Okay, next, which is in turn connected to an arm of a balance. Okay, that is maintained perfectly during the dissolution process. Okay, this is connected to an arm of a balance. When the dosage form is mounted on a aluminum strip, means here we are mounted the dosage form by using wax. With the help of wax, we are mounted on the aluminum strip. Okay, so after that what happens? The dosage form is restricting to the dissolution medium to only one phase of the dosage form. Means here restricting the dissolution to one phase of the dosage form only. Okay, it is exposing to only one phase of the dosage form. So this method is employed for the determination of intrinsic dissolution rate of the dosage form. Okay, the dosage form is exposed to one of the one phase of the dosage form only. So this method is useful for determination of intrinsic dissolution rate of the dosage form. And also it is need to compress the dosage form. In Nelson hanging pellet method, we need to compress the dosage form under high pressure. Why? What is the reason? To prevent disintegration. Okay, and also maintain constant surface area. Okay, this is Nelson hanging pellet method. Here also we are maintaining constant temperature. Next one, Levy static or disk method. Next method is Levy static or disk method. So this method is developed by the scientist Levy. Okay, this method is also called as static version of rotating disk method. This method is also called as static version of rotating disk method. Okay, this is the figure of Levy static disk method. So this is consisting of an acrylic holder. This is an acrylic holder. Okay, on which the dosage form is mounted. So here dosage form is mounted. And this total assembly is inserted through a rubber stopper. This is a rubber stopper. This assembly is inserted through a rubber stopper into a known volume of dissolution medium. Okay, that is the dissolution medium is here we are using 25 ml of simulated gastric fluid. Okay, 25 ml of simulated gastric fluid we are using. So after that, the vial is inverted and placed into the incubator at 37 degrees centigrade. Okay, after that, the vial is removed from the incubator. The solution is analyzed at the specific time intervals. So the solution is analyze. After removing the incubator, we need to analyze. The disadvantage effect of concentration on dissolution medium is ignored, and the surface area of the dosage form is, while dissolving, is assumed constant, which is not impractical. This is about levistatic disk method. Next one, forced convention non-sync methods only. This is the second one. In this, I think 4 methods are there. First one is the tumbling method. Okay. So, in this tumbling method, drug or dosage form with the dissolution medium, okay, with the dissolution medium is placed in the test tube. This is the test tube. This is the test tube. So, drug or dosage form is placed with the dissolution medium in the test tube. Okay. So, this is the test tube. This is the dosage form. And this is the rotating drum. This is rotating drum. The drum is rotated at the speed of 6 to 12 RPM. The temperature is maintained 37 degrees centigrade. Okay. After mounting the dosage form in a test tube, the drum is rotated at the speed of 6 to 12 RPM in a water bath. And after that, the test tubes is removed and medium is assayed for the regular time points for the dissolved drug content. Okay. We will take the samples and we will analyze. This is the tumbling method. Next one is the beaker method. Okay. This is the beaker method. In beaker method, this is also called as Levy method. Why? Because this is reported by Levy and Hayes in the year 1960. Okay, this method is developed by Levy and Hayes in the year 1960. This is consisting of dissolution medium, am I audible to everyone?
Yes, ma'am.
Yes, ma'am.
Okay. So this is consisting of dissolution medium, 250 ml 0.1 normal HCl and 400 ml beaker. Okay. This is thermoregulated dissolution vessel. This is thermoregulated dissolution vessel. This is stirrer. Okay. This will rotate at the speed of 60 RPM. Okay. This is wing blade stirrer. This is wing blade stirrer. This is dissolution medium. This is the dosage form. Okay. So in this beaker method also, we are maintaining temperature. That is, temperature bath is adjusted to 37 degrees centigrade plus or minus 1 degrees. Okay. So in this beaker method, take the dissolution medium, 250 ml of 0.1 normal HCl at 37 degrees centigrade, placed in a 400 ml beaker. Okay. After that, agitation is done by 3-blade polyethylene stirrer. Okay. This is the stirrer, no? Polyethylene stirrer, no? So, agitation is done by this stirrer. And this will rotate at the speed of 60 RPM. And here they are maintaining some conditions. Stirrer is immersed. Stirrer is immersed in a depth of 2.7 centimeter in medium. Okay. And also this stirrer is keep at the center of the beaker. At the center of the beaker. So after adjusting all these conditions, Tablets are placed in a beaker. Test is carried out. Okay. The specific time intervals, take the samples from beaker and assay for the content. This is about beaker method. Okay. This is about beaker method. Next one is rotating disc method. Rotating disc method. This is the assembly of rotating disc method. So this method is developed by late Eno Nelson and it is described by Levy and Sahil. So this apparatus is consisting of plexiglass holder. So here it is there, no? This one, this rectangle one. This is the plexiglass holder is there. So the drug is mounted on plexiglass holder. So this is the drug. This is the plexiglass holder. The drug is mounted on this plexiglass holder. So here also, like previous one, the aluminium strip one, the aluminium strip is also exposed only one surface, no, single surface of the disc, no. Here also, the drug is only single surface of disc is exposed to the dissolution medium. Okay. Next, this holder is attached to the metal shaft. This is shaft. So by using this metal shaft, steering speed is precisely controlled. Okay. Next, this plexiglass holder. Okay. This plexiglass holder is immersed in a 500 ml of dissolution medium. So this is the dissolution medium. Volume is 500 ml. And maintain the temperature is 37 degrees centigrade plus or minus 1. Okay. So this is a rotating disc. Next. Here we are maintaining some conditions. The holder, this one, the holder is immersed into a depth of 1 inch in the dissolution medium from this line to this line. So it is immersed in a depth of 1 inch in the dissolution medium. Okay. Next, this will rotate at the speed of 555 RPM. 555 RPM. In rotating disc method, the volume of dissolution medium is kept constant. Okay. The tablet in the holder and weight before and after the assay. Here we are mounting the tablet, no? So that is weighed before and after the assay. Okay. After that, samples are collected and analyzed. So from that, we will know how much amount of drug release content is takes place. Okay. This is the rotating disc method is one of the most accurate method. This is used to determine the intrinsic dissolution rate of solid dosage forms. That is rotating disc method. So here we are measuring dissolution rate measurements. Okay. This is the rotating disc method. The volume of dissolution medium is 500 ml. Maintain the temperature is 37 degrees centigrade plus or minus 1 degree centigrade. It is rotated at 555 RPM. Okay, this is the modified hydraulic pressure or metal shaft. The place mounting the holder, we will maintain the depth of 1 inch in the dissolution medium. This is the rotating disc. This is the rotating disc. This is the dissolution medium. This is about rotating disc method. So in the whatever we are placing the tablet in holder, no. So we need to weigh before and after the assay. So from that we will know after a collection of sample, after analysis, how much amount of drug is released. Okay, this is about rotating disc method. Next one is the particle size method. So this particle size method is developed by Edmondson and Lees in the year 1965. Okay. And this particle size method is the modified Beaker method. So Beaker method is there, no? So this is the modified Beaker method. Here we induce vigorous agitation. In particle size method, we are inducing vigorous agitation to suspend the particles. Okay. To suspend the particles that were undergoing the dissolution. Okay. So in particle size method, we will measure the changes in particle size. This is about particle size method. This is the modified Beaker type of method. Okay. Here we are using vigorous agitation to suspend the particles that is what undergoing the dissolution. This is about particle size method. Next one is the USB rotating basket. So everything is same. I already explained last class only. What are the conditions are there in rotating basket? One, what is made up of, shaft is made up of what? How much temperature we will maintain? So what is the use of this rotating basket? This is for useful for tablets, capsules, delayed release suppositories, floating dosage forms. So everything I already discussed. Rotating basket. So here some of advantages are there. Full pH changes during the test, and it can be easily automated, which is important for routine investigations. These are some of the advantages. Disadvantages is this is a paddle type of apparatus, no? So basket screen is clogged. Okay, clogging is there. This is one of the major disadvantages for basket type of apparatus. Basket screen is clogged with gummy particles. Okay, next, dead zone is there under the basket, and degassing is particularly important in this basket type of apparatus. And mesh gets corroded by HCl solution. Mesh is there, no, for basket, so that mesh will get corroded by HCl solution. These are some of the disadvantages for basket type of apparatus. Next one is a paddle type of apparatus. Everything is same like paddle basket type apparatus only. Okay. Here the steering elements are made up of Teflon. Water bath is maintained 37 plus or minus 0.5 degrees centigrade. Here sinkers are used. In paddle type of apparatus, sinkers are used. Okay, to prevent dosage forms from floating. Advantages is easy to use, robust, can be easily automated, which is important for routine investigations. Disadvantages. So pH media change is often difficult in paddle type of apparatus. And also sticking and floating problems are there. This will affect the drug dissolution. So all of you draw the dissolution apparatus very neatly with neat labeling. This is very, very important. The paddle type, basket type, flow through cell, everything. So you need to draw very neatly with labeling. Okay, label everything. After that, you will write like flowchart. Next one, forced convention sync methods. So these are the previously I discussed everything about non-sync methods. Now I will discuss about forced convention sync devices. Okay, I already explained what is non-sync, what is sync. Okay, in vitro dissolution test models can characterize the dissolution process. We can predict the bioavailability of the drug. In vitro studies, we can predict in vivo. By conducting of dissolution studies, we can predict in vivo condition. That's the reason we need to maintain sync condition. Okay, in vivo it is already available. The sync conditions are maintained, but in vitro it is not maintained. No? So we need to maintain sync conditions. Okay, so Why? Because the drug concentration in the dissolution medium does not exceed 10 to 20% of its solubility. The drug concentration is very high. That's the reason we need to change the dissolution medium to maintain sink conditions. So dissolution process one, which we will mimic the in vivo conditions by maintaining perfect sink conditions. So these perfect sink conditions can be maintained by these systems: fixed fluid volume, multiple phase, continuous fluid flow. Okay. In this first method is Brewster Poly adsorption method. This is developed by the scientist Brewster Poly in the year 1961. Better to write with the scientist names in the year also. Okay. Next. This is the dissolution medium. This is the shaft. The dosage form is placed here. Okay. In this, in the dissolution medium, here we are using in Brewster Poly adsorption method charcoal or bentonite. Okay. In the dissolution medium, charcoal or bentonite is present. Why? Because whatever the dissolved drug is there, no, that dissolved drug is absorbed by this charcoal or bentonite. Okay. Here we need to care one important thing, that is adsorbent. We need to take care of adsorbent. Why? Because the adsorbent only modifies the viscosity of the medium. Okay. So this is about Brewster Poly adsorption method. Next one is the partition method. So what is partition method? So this partition method is developed by Gibaldi and Feldman. Okay. The partition method was developed by Gibaldi and Feldman. This is the consisting of beaker and stirrer. Okay. In partition method, partition will take place. So in this, organic phase is employed to remove dissolved drug, so that the drug would partition between two phases, that is lipophilic and hydrophilic phases. So here we need to take care of organic phase. So selection of organic phase is very important in partition method. So here partition takes place, no? So selection of organic phase is important in partition method. Forced convention sink methods. First one is the Brewster Poly adsorption method. Second one is the partition method. Next, third one is the dialysis method. Next one is a rotating flask apparatus. So these four are come under forced convention sink devices. Okay. Next one is the dialysis method. Okay. So in dialysis method, so these are the dialysis devices. The first one is a rotating cell. This is the rotating flask and external dialysis one. This is the oscillating cell. Okay, this one is a rotating cell. This is the rotating flask and external dialysis and oscillating cell. So the use of this dialysis method is here we are using dialysis membrane. Here in dialysis method, we are using dialysis membrane. So the dialysis membrane is maintain solute concentration with disturbing dissolution process. Okay. The dialysis membrane is used to maintain solute concentration. Okay. This method is useful or possible to carry out dissolution studies under sink conditions. So dialysis method is useful for carry out dissolution studies under sink conditions. So this is consisting of dialysis cell. Okay, this is consisting of dialysis cell. In this, we will take dialysis membrane. So Here we are taking dialysis membrane. So the dialysis cell consisting of dissolution medium is one side of the dialysis membrane. This one, this side. One side is the dialysis dissolution medium is there, and dosage form is other side of the dialysis cell. Okay. This total assembly is rotated at the 15 rpm. The dosage form is placed here. The assembly is rotated at the 15 rpm. And after that, samples were withdrawn from the distal end at approximate intervals. Samples were collected and analysis will take place. In this dialysis method, selection of membrane is important. In every apparatus, there is one important thing is there. So in dialysis method, selection of membrane is important. Okay, selection of membrane is very, very important. So the membrane must have short equilibrium time and also adequate physical strength, and also it will retain solid particles. Okay, so the membrane must have short equilibration time, adequate physical strength, and also it will retain solid particles. Okay, this is about dialysis method. Selection of membrane is important. Okay. Next one, rotating flask apparatus. So the rotating flask apparatus, in this method, the flask containing dissolution medium, this will rotate under horizontal axis to the water bath. Okay, and this will, here we are maintaining temperature of water bath 37 degrees centigrade. Okay, here the flask is having the provision for sampling. Okay, here the flask having provision for sampling, so such that aliquots can be withdrawn from the medium. After that, after withdrawing the sample, we need to replace the fresh medium. Okay, means the fresh medium can be replaced back. So this is the rotating flask apparatus. The assembly is the dissolution medium is adjusted like this will rotated under horizontal axis to the water bath. This is keep it in the water bath. The temperature is maintained at 37 degrees centigrade. And also this flask having provision for sampling provision is there for collection of samples. After that, we will need to replace back of fresh medium. This rotating flask apparatus is suitable for oral solid dosage forms like tablets, capsules. Why? Because they do not require high agitation. Okay, so the tablets and capsules are not require high agitation. No, that is the reason we are using this rotating flask apparatus. Next, flow through devices. The flow through devices is in flow through devices is suitable for drugs which will saturate rapidly. Okay, the drugs which will saturate rapidly in large volumes of medium. Okay, for this USB apparatus will not serve this purpose. That's the reason this is a suitable device, is flow through device. This device is unlimited quantity of fresh dissolution is available. In this device, unlimited quantity of fresh dissolution medium is available. In flow through cell, The figure is